All right, this video is going to go over the test review for test 5A, so it's probably going to be a long video. Let's go ahead and get started. This first one, you're simplifying. So what you want to do is you want to factor it. The top is the difference of squares. The bottom is a trinomial. And then you cancel the binomials that are identical, and you write your answer. Okay, this next one, same thing. The top is a GCF. Your GCF is 4x, and when you take it out, you are dividing. Okay, and then the bottom is a trinomial. And then you want to cancel the binomials that are the same, and you get your answer. Okay, number 3, the top is a trinomial. Same thing with the bottom, it's a trinomial. Cancel your binomials that are the same. Okay. This next one, the top is a difference of squares. The bottom is a trinomial. Cancel the binomials that are the same, and you get your answer. Don't be the person that cancels like these y's. You don't want to do that. These are binomials. They have to be exactly the same. Now, having said that, look back at this problem. If we had gotten something like this, then yes, you could have canceled these x's because those are monomials and you can reduce monomials. So just keep that in mind. Let's keep moving. All right, number 5, we get to a multiplication. When it's a multiplication, you want to factor everything. So I'm going to go ahead and factor everything. It's going to be a -7. This top over here is difference of squares. And the bottom's a trinomial. And then same thing, you just want to cancel your binomials that are identical. So when it's all said and done, you get x plus 3 over 2x minus 7. Okay, same thing for the next one. Since it's a multiply, you just go and factor everything. So the top is a trinomial. The bottom is a GCF here. This is a GCF of 9. Take it out and you divide when you take it out. This is a GCF as well. And the bottom is a difference of squares. Okay, now cancel things that are the exact same. And then like in terms of this 6 and this 9, you can reduce these. They're both divisible by 3. So now you're ready to write your answer, which would be 2x plus 3, that's left on top. And on bottom is 3x plus 8. Okay, next up. Now we hit the divides. When you have a divide, you're going to want to flip this fraction on the right And so it's really, the problem really should look like this. Now it becomes a times. And this fraction on the right flips. And then once you get it to here, then it's the exact same as like the ones we were just doing. So you just want to factor everything. Then you just want to cancel. And that looks like everything that cancels. So now I would write my answer, which would be x plus 1, x plus 5 over x plus 2. Okay, so same thing over here. As soon as I see divide, I'm flipping this fraction. So it's going to look like this. This first part doesn't change. Now it's times though, and you flip it. All right, now you could go and factor everything. So this first part is a GCF. Your GCF is 3x squared. When you take it out, it's going to leave x minus 3. The bottom's the difference of squares. And then this one's a GCF as well. The GCF is 2. All right, now I'm ready to cancel. And then that's all that cancels. So my answer here would be, I have a 3x squared on top. I have an x minus 4. And on bottom, I have a 2. And I have an x plus 4. So that would be my answer. Now, one thing I haven't been talking about is restrictions on the variable. You can't, does it say it up here as well? Yes, it does. Okay. Restrictions on the variable mean whatever the denominator, whatever x value in the denominator would make 0. So like what I mean by that is if this said -2 right here, that would mean that I'd have 3y plus 1 over 0. That's undefined. That's not allowed. So basically, to find these restrictions on the variable, you just want to take the denominator, set it equal to 0, and solve. And this is actually what x cannot equal. That would be the restriction. So like this one, x could not be -4. This one, x could not be -6. Y could not be -6. Okay, now this one is a little trickier. You have to take that 2x minus 7, set it equal to 0, and solve it. So I'll show my work on that one. Add 7. Divide by 2. X could not be 7/2. Okay, this one, you don't do anything with the 3. You only do this when there's a letter x down there. So like this x plus 8, yes, x could not be -8. But the 3 you kind of ignore. So this one, x could not be -2. X could not be -4. I'm ignoring this 2 because there's not a letter x there. So that's what it means when it says restrictions on the variable. Okay, now we get to the adding and subtracting. Look at number 9. The first thing I would do is I'd get rid of this minus sign. I don't like it. So you can get rid of it and call it a plus as long as you distribute it to the top of the fraction to the right of it, which means it changes those signs. Okay, and so now you look for a common denominator. You can't add or subtract fractions without a common denominator. So these already have one. So now I can just combine the numerator. 5x plus negative 2x is 3x. Negative 3 plus 1 is negative 2. And that's just over your common denominator. You don't cancel anything on the adding and subtracting. Okay, this next one. They have a common denominator. So just go add numerators. I don't do that distribution thing because it's already a plus in the middle. So negative 6x plus 3x is negative 3x. And then you have that plus 4. And it's over that 2x plus 3. Okay, this next one is where they step it up a notch. These do not have a common denominator. You have to get a common denominator. The common denominator would be both of those denominators together, like this. So what you're going to have to do is, like this x minus 5, you have to give it to the fraction on the left. And like this x plus 2, you have to give it to the fraction on the right. And what's going to happen here is you're also going to have to distribute. And you're going to have to distribute this 5x as well. And so basically what you're going to get is, I guess I'll write it in red. You're going to get 6x minus 30 on the left. And on the right, you're going to get 5x squared plus 10x. And then once you get it here, you can just go combine numerators. So you have 5x squared. You have 6x plus 10x, which makes 16x. And then you have minus 30. And it's all over that common denominator of x plus 2, x minus 5. Okay, this next one, same thing, but when I look at it, the first thing I see is this negative. I'm going to distribute that to the numerator of the fraction to the right. So it looks like that. Now I can focus on common denominators. This fraction over here needs x. This fraction on the right needs 3x minus 1. Don't forget you're going to have to distribute. So on the left, it's going to become 4x squared on top over your common denominator. I'm just going to write it in black on this one. It's going to be too confusing. 4x squared on top, common denominator on bottom is x, and 3x minus 1. Now it's a plus in the middle because we changed it. And then it's on the numerator up here, it's going to make minus 21x plus 7 over the common denominator. And then once you get those common denominators the same, you can combine the numerator. So you're going to get 4x squared minus 21x plus 7 over the common denominator. Okay, this next one, same thing. But when you give this one on the left, the x minus 3, hold on one second. Let me go ahead and set this up. All right, so on the left, right here, you're going to have to run FOIL because you have a binomial times a binomial. So the FOIL there would look like x squared minus 4x minus 3x plus 12, which is really like x squared minus 7x plus 12. And it's over that common denominator. Just keep those separate. Okay, plus, and then on this side, you can just distribute because it's just a monomial times a binomial. You only run that FOIL when it's binomial. So, all right, so this one would make 32x plus 40 on top, and on bottom is that common denominator. Okay, and now that you're here, you can combine the numerators and get your answer. So your answer here would look like x squared. Negative 7x plus 32x is 25x. 12 plus 40 is 52. And then it's over your common denominator. Okay. Next up, same kind of situation. On the left side, you're going to give it the 2x plus 5. On the right side, you're going to give it the x minus 5. And right here, you're going to have to run FOIL because it's binomial. So that's going to look like this. X squared minus 5x plus 2x minus 10. So x squared minus, oops, not 7, it's minus 3. X minus 10. Okay. All right. So writing this one out on the left side, you can just distribute that x. So you're going to get 2x squared plus 5x over the common denominator. And then on the right, when we ran that FOIL, so I'll do it in red. And it's over the common denominator as well. Now you can combine the numerators. 2x squared plus x squared makes 3x squared. 5x minus 3x is 2x. And then you have that minus 10. And it's over the common denominator. All right, this next one, they're really stepping it up a notch now because they're giving you some trinomials. Well, the first thing I'd do is I'd notice that minus sign and I'd get rid of it. Okay, the next thing I would do is I would factor. So on bottom here, you're going to have x plus 7, x plus 1. And over here, you're going to have x minus 4, x plus 1. So your denominator, when you get the common denominator, there's 3 different puzzle pieces here. You have a red that they share. You have a green that this right side needs. And you have an orange that the left side needs. Like that. So when it comes down to it, in your denominator, both of these are going to have the red the green, and the orange. That's how you would get that common denominator. So up top, what's happening is over here you need to distribute, and over here you need to distribute. So you're going to get 2x minus 8 on the left, and you're going to get negative 1x minus 7 on the right. And now you can combine the numerators. 2x plus negative 1x is just 1x or x. Negative 8 plus negative 7 is negative 15, and then it's over that common denominator. Okay, and then the last one here, same scenario. You've got trinomial on bottom, so I would start out by factoring it. Okay. The guy on the left needs that x plus 1. That's the only part he's missing. The guy on the right needs x plus 5. That's the part he's missing. See now how they would both have all 3 of those pieces? All right, so up top, you're going to have to distribute. So it's going to look like this. 8x plus 8 over all 3 things. And that's plus. Distribute over here as well. You get 3x squared plus 15x over all 3 things. And then you can combine the numerators and finish this problem. So it would be 3x squared. 15x plus 8x is 23x. And then you had that plus 8. It's over all 3 of those things, the common denominator. Okay. All right. So there's multiplying and dividing. There was adding and subtracting. And now we get to solving. Now solving is kind of similar to adding and subtracting. Essentially, you want to get a common denominator. So like, look at this one, for example. They do not all have the same thing. The common denominator here would have to be all those pieces together, like 4 and x plus 3. All right, so being able to see a common denominator is huge. So look at this problem, 17. First thing I'd do is put that 3 over 1. Second thing I'd do is I'd get rid of that minus sign, make it a plus, and call it negative 3 over 1. Now you have to get a common denominator, and the common denominator is all 3 of these puzzle pieces. But x plus 6 repeats. So really you can think of it as 2 puzzle pieces, a 1 and an x plus 6. But if you stick a 1 down here, it's not going to change anything. So really your common denominator is just x plus 6. So that means to make all 3 of these equations be over x plus 6, this negative 3 in the middle needs x plus 6 on top and bottom. And so you're going to have to distribute that. So you can rewrite this problem like this. 8 over x plus 6 did not change. Now the middle becomes negative 3x minus 18 over x plus 6. And then it's equals to 2 over x plus 6, like that. Okay, and the reason you want to get all of these denominators the same is because now you can ignore the denominator, and then you can just solve the numerator. So now it's just a simple like 2-step algebra 1 equation. I get your x's on one side, number on the other. So I'd be minusing 8, adding 18. So you're going to get negative 3x equals 12. And then you just divide by negative 3. X equals negative 4 would be my answer. Now there is one more thing you have to check when you go solve these. You have to check for, remember those restricted values like x could not be negative 4? Well, that still applies here. So just looking at this, x could not be negative 6 because of this right here. But that doesn't matter because our answer was negative 4, which is fine. So like looking at number 18, the 4 doesn't give you a restricted value because it doesn't have the letter x, but this x plus 3 would. It would tell you that x could not be negative 3. So if we solve this and we get an answer of negative 3, that means it's no solution. But let's see what happens. All right, you have to get that common denominator again. So the common denominator is going to be both of these pieces, 4 and x plus 3, which means the ones that just have x plus 3, they need the 4 as well. The one that just has the 4, it needs the x plus 3. And then this one just has the x plus 3, so it needs the 4 as well. So you can rewrite this problem like this. 24x over common denominator plus 3x plus 9. Don't forget to distribute here. 3x plus 9 over common denominator equals 12 over common denominator. Now that the denominator is all the same, you can basically ignore it and just go solve the top. So you'd get 24x plus 3x plus 9 equals 12. So 27x plus 9 equals 12. Subtract 9. And then divide by 27. Get x equals 3 over 27, which is actually 1 over 9. And that seems kind of like a weird answer. So if I got an answer like that, I would probably be checking it. I'm going to pause the video real quick and check it. All right, so I checked it and it checked out. It's the correct answer. And if you're wondering how I'm checking it, basically you just take this answer and you plug it in for all these x's and you see if it, like when you solve it, you get the same number equal to the same number. So if that checks out, it's the correct answer. Let's keep moving. All right, number 10, or 19, sorry. Okay, these things that don't have a denominator, put them over 1. So when it comes to your common denominator, it's going to be 1 and n, or just n, because timesing by 1 is not going to change anything. So what that means is this fraction on the left needs n over n. This guy in the middle, he's already got n. He's already good. And then the one on the right, you need n over n. So when you rewrite it, it's going to be like this. N squared over n plus 15 over n equals 8n over n. And by the way, this n on bottom gives you a restricted value that x cannot be 0. So just keep that in mind as we get our answer. All right, now that the denominator is the same, you can kind of ignore it and go solve just like n squared plus 15 equals 8n. This is a quadratic, and when you're trying to solve a quadratic, generally you want to make it equal to 0 so that you can factor it. If you factor this, you get n minus 5, n minus 3 equal to 0. The reason you want to factor it is because once it's factored, you can just set each factor equal to 0 and solve. N is 5. And then this one as well, n minus 3 equals to 0. Add 3, n equals 3. Okay, moving right along. This one, you need to get the common denominator, which would be both of these pieces, x plus 2 and x minus 2. So that means the fraction on the left needs x minus 2. The fraction in the middle needs x plus 2. The fraction on the right needs x plus 2. That's a 2. Okay, and up top, just don't forget to distribute when you do this. So here's what it's going to look like. It's going to look like 3x minus 6 over both of those things, x plus 2 and x minus 2, plus 9x plus 18 over the common denominator equals 6x plus 12. Why is this so difficult for me to write it to? Plus 12 over the common denominator. And now you can kind of ignore the denominator. Just, I would also be thinking about my restricted values. X could not be 2 and X cannot be negative 2. So if we get any of those answers, it needs to be tossed. But basically you could ignore the denominator and just go solve the numerator. 3x minus 6 plus 9x plus 18 equals 6x plus 12. Combine like terms on the left side. 12x plus 12 equals 6x plus 12. Subtract 12, or get your numbers on one side and your x's on the other. So I would be like minusing 6x and minusing 12. What you're going to get is 6x equals to 0. Divide by 6, x equals 0 would be my answer. Okay, moving right along. 4 more to go. We're almost there. Now this one, you need to factor this trinomial first. You'll realize it's x minus 5, x plus 2. And so your common denominator is going to be both x minus 5 and x plus 2, which means the fraction on the left needs x minus 5. This guy in the middle doesn't need anything because he's already got both of them. And then the guy on the right needs x plus 2. Just don't forget to distribute when you do these. All right, so it's going to look like this. 2x minus 10 over common denominator. The middle, or sorry, equals, the middle one did not change because it already had the common denominator. And then plus 3x plus 6 over common denominator. And this common denominator tells you that x cannot be 5 and x cannot be negative 2. All All right, now you can basically ignore it and just go solve the top. 2x minus 10 equals 15x plus 3x plus 6. Combine like terms on the right side. Get all your x's to one side and all your numbers to the other. You're going to end up with negative 16 equals 16x, and then divide by 16. You get x equals negative 1. Okay, this next one, the common denominator is going to be both of these puzzle pieces. So that means the guy on the left needs the 3. The guy in the middle needs x minus 6. And the guy on the right needs the 3. So when you rewrite this, it's going to be 6x over common denominator plus x minus 6 over common denominator equals 15 over common denominator. And this common denominator just tells you that x cannot be 6. Remember, we ignore the 3 because it doesn't have the letter x attached to it. Now you can basically ignore the denominator and go solve the numerator. Combine like terms. Move the minus 6. Divide by 7. And I'm good to go. Okay, 2 more. Both of these puzzle pieces are going to be your common denominator. So the fraction on the left needs x minus 6. Fraction in the middle needs x plus 6. The fraction on the right needs x minus 6. So it's going to look like this. Just don't forget to distribute. You get 2x minus 12 over common denominator plus distribute 3x plus 18 over common denominator equals distribute 6x minus 36 over common denominator. All right, this denominator is telling you that x cannot be negative 6 or positive 6. So if we get those answers, they get tossed. Now, ignore the denominator, go solve the numerator. So it's going to look like this. 2x minus 12 plus 3x plus 18 equals to 6x minus 36. Combine like terms on the left side, you get 5x plus 6 equals 6x minus 36. Get your x's on one side, numbers on the other. You'll end up with 42 equals 1x. That would be my answer. Okay, and then this last one. Well, it looks like they saved the easiest problem for last because the denominator is already the same. So this denominator just tells you x cannot be 5. And then you can just ignore it and go set the numerators equal to each other. So 2x minus 15 equals 3. Move the minus 15. X equals 9. If you made it this far, just be advised that none of them showed up where we had the restricted value, but let's do this and imagine we got x equals 5, but x couldn't be 5. This answer would get tossed and your answer would be no solution. Okay, so just keep that in mind. That was just hypothetical though. My answer is 9 for that last problem. Okay, so that's how to solve. See if I can get a good screenshot. There we go. That's how to solve rationals. You want to get a common denominator and then set the numerators equal to each other. That's how to add and subtract these rationals. It's all about the common denominator there. You don't want to cancel anything really. And then how to simplify and multiply and divide them. That's all about canceling things. So there's your test review. Hope this video helped.